IP address is a software address. It's a software address, and we give it to our PCs and other network devices. IP is also called Internet Protocol. It's called Internet Protocol. What is a protocol? Its protocol is basically a language, right? It's kind of a rules of communication. Okay. So if we need a PC to talk to another PC or a laptop, we would have a switch or a hub having multiple ports with network cable connecting them. Or we might have a wireless router beaming Wi-Fi network connectivity to computers in the LAN. Okay. Is this visible? Should I move the board?
No, it's good.
It's good. Now, in order for them to talk to each other, we give an address. Okay. For example, let us assume this has an address of 10.5.5.5. Okay. And now we have 4 devices in the network. The switch itself will have an IP address. For example, 10.5.5.1. The Wi-Fi laptop has an address 10.5.5.2. And the router itself has an IP address, say for example 10.5.5.3. Now this address is used to identify each of the devices on the network. No two computers can have the same address. If they have a same address, there will be a collision. Suppose if this device over here, this laptop, and this computer has the same address, then your router or your switch will not know where to send the packet. So that is why we keep unique addresses for each devices on the network. Also, as I mentioned, we need to identify the network part of the address and the host part. In this example, we see that first 3 part of the address is same in all the computers. Same. See this? The same for all the computers. And that's why we say this is the network part. This part of the address is called the network part. Network address. And this part we say, which is different for every computer. It is called the host address. Okay. Network address, host address. So we see that the network address is same. Network address is same for all the devices in the LAN. While the host address is changing. This is the host address. This is the host address. This is how a typical network is given IP address. Okay, this is how a typical network is given an IP address. Any doubt about this? Any questions about this? Okay, now for example, I have one department. Okay, this is called HR department. Okay, and I have another department called sales department. And I have another department over here, or let's take this itself, and we have a switch, company switch at the backbone. This is the symbol of a Cisco switch. Okay. And we have lots of ports. Okay. And we have PCs in HR, and we have PCs in sales. Okay. Now our company has to be designed accordingly so that both of them are having separate networks. The bosses, they don't like to be in the sales department network. Their laptop should be in a separate network. That's what they request, because they have a lot of confidential traffic over here. Confidential traffic. Okay? And the sales guys are busy sending emails to their clients, and there's a lot of, the volume of traffic is more over here. The volume of traffic is less. So they don't want to be disturbed by these guys. So they'll say, could you please make two separate departments for us, and see that this is this works out well. Now, for two computers, you wouldn't go out to buy a switch. If the minimum you would buy is 8-port switch or something like that. So we need to keep two different switches, which is an expensive solution. So you would rather buy one switch and logically split the switch in two parts. Logically, if you are a kung fu guy and you jump in the air and just come down with your knee and crack the switch into two switches, it's like that, two separate parts of the switch, half switch here, half switch here. So that is what you are trying to do. Okay, you want to split them out. Okay, this is for the sales, this is for the HR. Okay, you want to split it out. You're a very strong guy, and you want to split it out for them. So we are doing it logically, we are not doing it physically, because usually we get a switch for about 8 ports, 12 ports, 24 ports and things like that. Those are much better solutions. So you would buy something like that, and now your job is to separate their traffic. So what you would do is, you would create a virtual LAN for the HR, and another virtual LAN for the sales. So you'll create two virtual LANs in your switch, virtual, so the traffics don't talk to each other at all. Okay. In the physical switch, all the ports are talking to each other. When you just bring a switch, brand new switch, take it out of the box and connect the sales guys' PCs and the HR guys' PCs, they'll be able to see each other. When you do network neighborhood, you'll be able to see all the pieces together, but you don't want that. So basically, this is what happens in all the networks. They logically cut the switch in two parts. Not two parts, you can cut it into 1,000 different parts, logically, just software-wise, and assign ports to it. So I'll say this is VLAN HR, and this is VLAN sales. Okay, that's what I'll tell them. And I'll say all these 4 ports are for the sales guys. And I'll say, okay, VLAN HR, all these 4 ports are member of this VLAN, and I'll give a connection to this network over here. Okay? There might be 2 cables for 2 computers, or something like that. Might be 2 for 2 over here, something like that. And 2 are still not used. Maybe for future sales guys, maybe for future HR guys, there are 2 spare over here. So we have a basic network being modified in a commercial environment now. That was a simple basic network. Now we have another dimension to our understanding of how the networks are made. Okay, we are network guys, okay? Whatever we do is networks, that's it. Now we can make great networks, we can design excellent features to that. So this is how a simple network is made. We get a contract in market, okay, please come in, we've got a showroom, we'll give you 15,000, could you make a network for us? Okay, we'll do it. In 1 week you can do the job, maybe less than 5 days, 4 days, you can finish this job. You can go in and start configuring them. So this is how the things are. Now, we have done a VLAN, we've created a virtual LAN for both the departments, but what about the IP address? You have to choose an IP address for these 2 computers and for these computers. Okay. So you might come up and say, okay, let me give this address, 20 network, okay, 20.0.0.2 for this computer, and 20.0.0.3 for this computer, and this VLAN itself I'll give an IP address 20.0.0.1. Okay, so that makes my VLAN. My one network is ready. Okay. Now just looking at that, I understand that I've missed out on my subnet mask. Let us keep the subnet mask in such a way that it just falls under the network address. So I have chosen my network address to be 20. All computers will have that number same. And the rest I'll just keep it 0 for the host. So 255 is my subnet address to identify this is a network address, and all zeros are for identifying that this is the actual computer address. Now it is complete. Any questions of this? Does this make sense? How we have come up with a simple, very basic, small network. Okay. Same thing we are going to do it over here, but we are going to keep a separate or different network address so that the traffics don't talk to each other. Okay. One is speaking French, one is speaking Spanish. They don't talk to each other. They don't understand what he's talking. So that's why the address, the software address has to be different, because if the address is same, they'll be able to hear their traffic. They'll be able to listen to what's happening in that network, which is bad. We don't want people to sniff the traffic. They can run a small sniffer in their LAN. Lots of sniffers are available on the LAN, on the internet. You can download it, you can sniff. And if this network is having the same range of IP address, or sorry, network address, then they will be able to sniff what the bosses are doing, where they are sending the quotations and things like that. So we'll keep this traffic separate by giving different network address. For example, I'll make it 30 is my network address for all the computers, and even the VLAN software address is 30. Okay, and then I'll give the actual IP address for the PC. 0, 0, 2. That's the PC IP address. 0, 0, 3. That's this PC IP address. And 0, 0, 1. Okay. I've given IP address for them. Okay. Now the last thing I have to give is the mask. The mask is going to say that okay, 30 is the address for this network. Network address. How do we identify network address? By writing the mask just below that. Okay, so now we know that this is 30, network 30, 255. We'll look deeper into the addresses later on, but we want to make our understanding very solid. Our understanding of how networks are made very solid right now. Okay, without going too much deep, and now my networks are ready. This network is this is a 30 network. Okay, 30 network. That's the network address, and this network address is 20. So they will never talk to each other. They will not be able to understand what's happening in the other network. But if this guy wants to talk to him, he can talk because both of them are in the same network. Whenever he does broadcast, hello everybody, his hello packet will be heard in this network only, in this VLAN only. Okay? And if he does, .2 is trying to find this one, and he's connected to port number 8, for example, and he says hello everybody, so his packets will enter the switch, and switch will send it out through all the ports. Hello everybody, except the port from where it learned about it. So all the computers will come to know that somebody is doing a hello. And then they will listen, wait for some time and listen his message. I'm trying to talk to .3. Could you, whoever is .3, please send me your MAC address. I want to start communication with you. So .3 will send his MAC address on the LAN, on this LAN. From here it will come out to the switch, and the switch will get the MAC address of .3, start communication, file transfer, photo transfer, emails, sharing a folder, printing a file across the LAN, everything can be done. Same thing for these guys. When he does network neighborhood, he'll be able to see only these two people. The only two guys in the LAN. And whenever he does broadcast, or this guy does broadcast, hello everybody. So his broadcast will go to his VLAN and come out of the switch ports of these 4 switch ports. If there are 4 computers, all the 4 will listen to it. This is how they talk to each other. Okay, this is how we make virtual LANs. We split the switches into different departments. Okay, this is how we are using IP addresses in the LAN. Okay, any questions here? No? Now the question comes is, what if the boss over here tries to talk to a salesman? We have cracked the switch in 2 parts logically by making virtual LANs. So what if the boss is trying to send something, some quotation to the sales guy, the sales guy has to send to the customer. So what will happen? How will we make it possible for their computers to communicate with the sales guy's computers? We need to find a way by which 2 different networks talk to each other. And the only thing possible is to use a router. A router is a device, a box that connects one network to another network. Okay? So we'll have a small router. Okay? We'll have a small router like this, for example. The symbol of the router is like this. And the router will have an Ethernet port going to the switch. Any of the port, doesn't matter. but that port has to be a trunk port. Okay, suppose it's going to a port number 9. Okay, that port has to be a trunk port, and it should allow traffic of VLAN 1, sorry, VLAN sale, HR, and VLAN sales. Both the traffics should flow on this. Okay? Router will, this is the Ethernet port of the router. Router will make it possible for the traffic to talk to each other. We just need one connection for the router. Okay? Any one connection. Here only VLAN sales traffic is coming. VLAN sales, VLAN HR. But on this port number 9, both the VLAN traffics are coming. You configure it. So it has to, or your boss's traffic has to go to this VLAN, any of these 8 ports, and from the switch it has to go to port number 9. It has to go to the router, and the router will send it out. It will come here, and the router will translate the traffic from VLAN sales to VLAN HR, and will push the traffic to the sales guys. This completes the communication of a given network, commercial environment. Okay. We can extend the router to accommodate our DSL modem. Okay, and this goes to your ISP, your telephone cable. Okay, by doing that, we are allowing each one of them to go to the internet. See, each one can go to the internet through his VLAN, to the router, the DSL modem, up to the ISP. So he'll have internet. See how we are building up small network. My goal is to establish kind of confidence in while we are learning, so that we become more confident and how to make small networks and how to grow vertically up, right up till the internet cloud. Okay, our traffic should be able to go up and down like that. See, any questions about this? Now we can use any kind of addresses. In this example, we have used class A address.